So this is a good one. It's something that's not easy to wrap your head around because it's kind of counterintuitive. I mean, if you were thinking about trying to calculate the bore diameter and you wanted more force, you could just have a larger bore and then you'd get more force. But the thing is, if you want a certain amount of force in retraction and you use a larger rod, well, you get less force. And that's actually because the rod diameter, if it gets bigger, that means there's less surface area on the retraction side, so you have less force. So the way to make more force is actually make a smaller diameter. So you just have to think backwards when you're doing the math. So this is the situation. We have a bore of 2 inches, and we have a rod diameter that we don't know. Now we need a force, and the force is a nice range. It's anywhere between 110 and 125. So we have to then calculate exactly what the rod diameter would be for 110. Or you could do it 125. I start with the lower number. So calculate exactly what the rod diameter will be if you were to apply exactly 110 pounds of force. And then from there, you will have to then size it probably smaller than that. Actually, you will have to size it smaller than that unless you get the exact number. If you actually calculated exactly 1 inch, you're good. But if you calculated something like 0.9 inches, well, you couldn't go to an inch because then it would be larger. You'd have to go smaller. Let's take a look at the math. So what I've got here is I'm working with a bore of 2 inches, and I have to select the rod so that my retraction force will be in between 110 and 125 psi, or pounds of force, pardon me. So, okay, so what I want to do is I want to take my 110. I mean, I work with the lower number. You can start with the higher number and work down, or either or. So I'm just going to take this value and I'm going to say, hey, what rod do I need to create that exact amount of force if I'm working with 75 psi, because that's my working pressure. So good. So I'm going to plug this into this formula here, and that is giving me 1.46 inches. Now, this is interesting. If you think about this, for the bore diameter selection, like, I mean, you know, if you're selecting just the bore diameters for extension force, and you calculate a value that's 1.46, say, inches for a bore diameter, you can go to 1.5 easy. You can say, yeah, I just increase the bore diameter a little bit because then I'm going to increase my force, and that's good. But in this case, it's the opposite. Yeah, take a look at this. If I increase the area of this circle in the middle, if I increase the area of that, or the diameter of this, then I have less area. Therefore, I have less force. So what I need to do is I need to decrease the rod size, because, you know, I'm going to find, it actually, listen, this is interesting. It'll be a little bit odd to find a cylinder with a bore diameter of 2 inches and a rod diameter of 1.5. You can get them. You can order them. They're around. They're available. Just they're a little bit more rare because often we want a little bit more surface area on the retraction side. So, but what I'm saying is you can still go get a 1.5 inch, but again, it's not going to produce enough force. It'll produce some force under 110, maybe 105, but it's not enough. So we want to go for a smaller bore diameter. So the next one down on the data sheet, when you go look up your supplier, or you get at the catalog and you're looking, well, all the ones are available, you'll see the next one down below a 1.5 is probably a 1 3/8. So I'm going to choose a bore diameter of 1 3/8, and then I'm going to recalculate to see how much force I'm going to get. So if I put this in my formula and I do 1 3/8, which is 1.375 inches, then I have a force of 124.25 pounds of force. And that's good because my maximum I can have is 125. So in my statement here, I'm just saying if I did select a rod diameter of 1.5 inches, then I'll have less area and my force will be below 110 because that says 110, as you can see. Okay, so therefore, I need a smaller rod diameter, and a 1 3/8 is going to give me 124 pounds of force. So I'm good. Okay.